Okay, so we looked at permutations last time where we have a group and we want to pick some subset of the group and order does matter, like 10 people in a race, talking about how many ways are there to come in first, second, and third. Now we're going to look at a situation where the order does not matter. So imagine we have 10 people in a race and we're just going to draw 3 of their names to get a trophy. And the trophies are identical, so the order we draw the names does not matter. So how many ways can we choose the first one? That would be 10 different ways times 9 different ways times 8 different ways. But here choosing ABC or BCA or CAB or any other one of those combinations is going to be the same. Rearrangements end up being the same thing because the trophies are identical. So what we now need to do is take this number and divide it by how many ways we can arrange those 3 things. And we know from last time that that is going to be 3 times 2 times 1. So we end up with 720 in the top divided by 6, and that is 120 different ways. So if we have 10 people and we want to choose a group of 3 and the order does not matter, we can do that 120 different ways. And we call that a combination. Permutation when the order matters, combination when the order does not matter. And the formula for combinations is right here, and you don't really need to know it, but it is NCK or N choose K, and we do N factorial in the top and divide by N minus K factorial and K factorial. So the difference here between last time and this one is before we just had this, right? If the order mattered, we had our 10 factorial divided by 7 factorial, which ended up being just 10 times 9 times 8. So it was just start with the 10 and do the first 3 numbers. The difference now is since order doesn't matter, we have to do the 3 factorial in the bottom, and that gives us what we're after. And I'm sorry, I just did this. That's the one with the numbers in it. That was just the general formula for your reference. Now, the way you're actually going to do this, you're welcome to do it this way. It's not very difficult. For smaller numbers or for few numbers, it's not much more work than just taking out the calculator is. But suppose we want to do it with the calculator. Start with the 10, the total number in the group we're choosing from. Then we go to Math, over to PRB, and down to NCR, or N choose R. I apologize again, I did K in my notes. It's R in the calculator. I don't think, the way most of my students spell, I don't think many will even notice the difference. So there we go, we get our 120. Okay, so that's how we use the calculator for permutations, combinations, and also for factorial we did last time. They all come from the same place in the calculator. Let's look at just a couple, and then I think I'm going to do one more of these just to practice this a little bit. So if we have 20 people, how many different groups of 5 can we choose? Now, is that going to be a permutation or a combination? If you're just choosing a group of 5, then the order does not matter. That's going to be a combination. So we want 20C5. We'll do the calculator in a second, but I want to show how really easy this is to do by hand. Start out with 20 and do the first 5 numbers. So 20, 19, 18, 17, 16. Got 5 of them up there. And then in the bottom, we just do 5, 4, 3, 2, 1. And if you want to, you can do this by hand. 5 times 4 is 20, so that cancels. 3 times 2 is 6, so that'll cancel with 18 and leave a 3 up there. And then all you really have to do is multiply 19 times 17 times 16 times 3, which you can do in your head. I can't. So let's go to the calculator. We can do 20 Math over to the left and down to NCR, and we're choosing 5 people, right? NCR because it's combinations, order doesn't matter, and that can happen 15,504 different ways. That answer surprises me a little bit, Most of these permutations and combinations are bigger than your intuition will tell you they ought to be, if your intuition's anything like mine. Right? What if we have a class of 20 people, and we need to choose 4 officers from that class, say maybe to represent on student council or something where you've got a president, a vice president, a treasurer, and a secretary. How many different ways can we choose those? Well, here it was combination because order didn't matter because it was just a group of 5 without any ranking. But here, one is the president, one's the vice president, one is the secretary, one is the treasurer. So the order does matter. That's going to be a permutation. So this would be 20P4. And that would be fairly easy to do by hand. It's going to be 20 times 19 times 18 times 17. Very similar to the numerator here. And then we just don't divide by anything. And if you want to multiply those together, you can. I don't care to. I want to go straight to my permutation key here. I got my group of 20, math arrow, down to the permutation key. And then we're choosing 4 from that group of 20. That's 116,280, right? NPR is always going to be bigger than NCR because the order does matter, so that's going to give us more possible combinations. So 116,280 there. That's quite a few ways to choose 4 officers from a class of 20 people. One more for this one, and then we'll move on. Suppose we've got a group of 15 people, and they all want to go to the movies, but we only have 8 tickets, so only 8 of them get to go. How many different ways can we choose the 8 people out of this group of 20? Well, this is going to be combination or permutation. The order doesn't matter. It's just that 8 people get to go, the others don't. So that is a combination. Order does not matter. And we start with the number that's in the group, so 15. And then combination, NCR, only the 8 get to go. And there's going to be 6,435 ways that we could possibly choose those 8 people. Okay, I think I'm going to come back and do just a little bit more with this. Not much, but I will see you next time.